Okay, in this video we're going to talk about geometric probability. Well, there's two definitions, one pertaining to length and one pertaining to area. So let's start with length. The probability that a point S on AB chosen at random lies on line segment MN is, and we denote probability by point S on MN, and it is the length of MN over the length of AB. So if you take a look at this, we're looking at the length of MN over the total length of the segment the point could lie on. The probability with respect to area is the probability that a point R chosen at random lies in the shaded region is, and we denote it as the probability of S in shaded, we'll say is the area of the part, which is the area of the shaded region. So it's the area of the rectangle minus the area of the triangle over the entire area, which is this whole area, including the triangle. All right, so let's go ahead and use our definitions to run through some example problems that you'll find on your worksheet. So it says a point T on AD is chosen at random, and I want you to notice that AD is not the entire line segment. A is here and D is here. So we're only talking at a point chosen at random on this segment. What is the probability that T lies on AB? Well, I think first we have to find the length of the total segment. So let's put numbers on A, B, C, and D. Well, this is 0, 1, 2, 3, 4. A is at 4, 5, 6, 7. B is at 7, 8, 9, 10, 11. C is at 11, and D is at 13. So we're going to find the length of AB, and we do that by subtracting 7 minus 4, and then dividing it by the entire length of AD. The length of AD is 13 minus 4. So we end up with 3 over 9, or 1/3. So the probability is 1/3. Let me rewrite that. All right, so how about AC? Well, we have to find the length of AC. AC is going to be 11 minus 4, and we're going to divide that by the total length of AD from A to D, so that's 13 minus 4. So we get 7 over 9. How about BC? The probability that that point lies on BC. Well, we have to find the length of BC, which is 11 minus 7 over the total length, which is 13 minus 4. So we get 4 over 9. And then how about BD? The length of BD is going to be 13 minus 7, and then the total length of AD is going to be 13 minus 4. So we're going to get 6 over 9, which is equivalent to 2/3. So you should always reduce your fractions when you're done. All right, let's move on to shaded regions. Here we have a shaded region, and I want you to notice it does say over here that all regions are of equal size. So because they're of equal size, we can treat them like their lengths. Okay, we have one region or two region or three regions or 2 out of the 3 regions. So it says what? Find the probability that the spinner, and imagine there's a spinner that's stuck here right in the middle. The spinner, which they usually look something like this, and I can't get it to stay above my colored spots. So anyways, imagine the probability that the spinner lands in the red region. Well, the red region is one region out of the total 3 regions. What's the probability that it lands in the blue region? Well, again, the blue region is 1 region out of 3 regions, so the probability is 1/3. The yellow or the red region. Well, if we combine the yellow and the red region, that's 2 regions, not 3, 2 regions out of a total of 3 possible regions, so the probability is 2/3. How about the probability that it lands in the yellow, red, or blue region? Well, that's 3 regions out of 3 regions, which is 1. That means every time it spins, it's going to fall in either the yellow, red, or blue region. And I know in reality there are black lines on that spinner, but they're so negligible and they don't give us any information about the black lines that we don't include them. All right, in the next example it says, find the probability that a point chosen at random falls in the shaded region. So here we're going to go ahead and use the area definition. We have to find the total area. So we're going to start with the squares first. I know they're squares because they have these marks on the side that tell me all the sides are equal. So the area of a square is side squared. So I'm going to square the 5 to get 25 centimeters squared. Okay, the area of the small square, so we're going to look at the small square, is area of small square. Again, it's side squared, so it's 3 squared, so I get 9 centimeters squared. So what is the area of the shaded region? Well, it's not the total area because the total area is the entire big square, even though this part shouldn't be counted, right? We have to take that part out. So the probability of it falling in the shaded region is going to be the total area, 25, minus the small square, 9, all over the total area again, which is 25. So what is 25 minus 9? It is 16 over 25. So the probability that it falls, a random point falls in that blue area, is 16 over 25. How about for these concentric circles? Concentric meaning that they share a center point. Okay, so the area of a circle is pi r squared, so we need the radius. So the radius is not 9, that's the diameter, so it's 4.5 for the small, but for the large circle, it goes all the way here. The diameter is 14, so the large circle has a radius of 7 centimeters. All right, so we have 4.5 and center, 7. So for the big circle, the total, not the blue, but the big circle, including the white circle, we know it's going to be pi, the radius is 7 squared. So we get 49 pi. The area of the small circle is going to be, that's going to be pi 4.5 squared, which is going to be, let's see, 16, 20.25, I think, 20.25 pi. All right, so how do I find the area of just the shaded region? I take the total minus the small circle, so I get 49 pi minus 20.25 pi all over 49 pi. Well, when I subtract 20 and a quarter, I am going to get, let's see, 28.75 pi over 49 pi. And my pi's will reduce out, so I will be left with 28.75 over 49, and that would be the probability. All right, so let's go ahead and move on to this next one. It says the target has a diameter of 28 centimeters. The inner circle has a diameter of 4 centimeters. The width of each ring, so this is 4 centimeters. The width of each ring is 2. 2, 2, and 2. All right, so this is going to be 2 as well, and you can't see that 2 because it's so small. A dart hits the target at a random point. What is the probability it lands in these various regions? So since we're looking at the center, the red or yellow, and the blue or yellow, we're going to find the total area first, the area of the entire circle. So I know that each one of these is 2, 4, 6, 8. So my radius, that's not, well, is it? Let's see. The inside one, the width of each ring is 4 centimeters, and the inner circle has a diameter of 4. So I lied. These are 4 centimeters, and the inner circle has a diameter of 4, so that's 2. So it's 4 and 4 and 4 is 12, and 2 is 14. So the radius is 14, so the area of the entire circle is going to be pi times 14 squared, which equals 196 pi. The area of the center ring is just going to be, it has a radius of 2 because the diameter is 4. So the area of just the center is pi times 2 squared. So it's going to be 4 pi. But the red ring does not include the yellow or the center. The red ring has a radius of, let's see, 4, 8, and 2 is 10. Pi times 10 squared, but we have to subtract the yellow and the white, the center. So the yellow and the white together have a radius of 4 and 2 is 6. Pi times 6 squared. So I know this is 100 pi minus 36 pi, and this is going to be 64 pi. The blue is going to be, I know I have, from the total, the blue will be 196 pi, but we have to get rid of the red, yellow, and the center, and the radius of that circle altogether is 4, and 4 is 8, and 2 is 10. So it's going to be pi times 10 squared, which is 196 pi minus 100 pi equals 96 pi. And then for the yellow has a radius of 4 and 2 is 6. So it's going to be pi 6 squared minus the area of the center, which we've already calculated to be 4 pi. So we get 36 pi minus 4 pi, which is 32 pi. Okay, so when we calculate these, we have to put the region over the total. So the center we calculated to be 4 pi, and we're going to divide that by a total of 196 pi. So the pi's will reduce out, and 4 does go into 196 nicely, so that's going to be 1 over 49. That's the probability that a dart will randomly land in the center. How about in the red region? Well, the red region has an area over here of 64 pi. 64 pi over the total area, which is 196 pi. So that is going to, let's see, I know 4 goes into everything. So this is going to be 16 pi over 49 pi, and then the pi's reduce out to give us 16 over 49. How about the red or the yellow? Well, the red and the yellow together add up to 64 pi plus the yellow is 32 pi. 32 pi over the total of 196 pi. So that gives me 96 pi over 196 pi. And I know that 8, I believe, no, 4 goes into both of them. 2, 24, and 49. 9. So